So we want to see if functions are symmetric with the y-axis or the origin. Remember, functions won't be symmetric with respect to the x-axis because then they don't pass the vertical line test. But we have two new terms for this. So a function that's symmetric with respect to the y-axis is called an even function. Okay, so if you can fold it along the y-axis and it matches up, it's even. So for example, x squared, right? So x squared looks like this. It's an even function. You can remember that because the exponent on it is even. An odd function is symmetric with respect to the origin. So you can remember origin, odd. Okay? So remember, just check if you're symmetric with respect to the y-axis. You're going to plug in negative x for x and see if you get the same thing. Okay? For an odd function, you're going to plug in negative x for x and negative y for f of x or g of x or whatever you have, wherever the y is, and see if you get the same thing. Okay? So when you first start out, if you want to replace that f of x with y, that's totally fine. Okay, and sometimes a function won't be odd or even, so it's not quite like numbers where you can talk about it being odd or even. Sometimes it'll be neither. So let's start out with f of x equals 7 over 4 minus x squared, and we can rewrite that as y equals 7 over 4 minus x squared. So let's check for even. So we're going to replace negative x. We're going to place x with negative x. So we'll leave y alone. Okay. And since the only place we had an x is this negative x squared is the same as x squared. So that does give us the exact same thing as we started with. So this function is even. And unless you're the constant function y equals 0, you can either only be even or odd. So once you get one, you don't have to check for the other. Okay, let's look at this next one. We've got g of x equals 7x cubed plus x plus 1. So we can replace it with a y first. And so we're going to plug in negative x to see if it's even. So y equals 7 negative x cubed minus x. So plugging that negative x plus a negative just becomes minus x plus 1. Now, when we do this negative x cubed, negative x times negative x times negative x is a negative x cubed. So this is going to become negative 7x cubed minus x plus 1. And there's nothing else we can do to simplify this, and it's not the same as we started out with. So this function is not even. Now let's check odd. For odd, we're going to replace both sides. So we're going to do negative y equals 7 times negative x cubed minus x plus 1. Okay, so let's go ahead and do that. Negative x cubed, remember, becomes a negative x cubed, so negative 7x cubed minus x plus 1. And to check if it's really the same thing, we want to get y by itself again. So we're going to multiply both sides by negative 1. And we'll have to distribute the negative 1 on the right-hand side. So we get y equals 7x cubed plus x minus 1. That's negative 1 times the 1. Now that's really close to the beginning, but we have a minus 1 here where we had a plus 1 there. So it's not odd either. So this one we would say neither. Okay. It's actually pretty difficult to get an even or an odd function. So you will see neither show up. Okay, for C, we've got 9x over 7x cubed minus x. So we can replace the h of x with a y. Okay, so let's first check if it's even. So we're just going to replace x with negative x. So we'll have y 9 times negative x over 7 negative x cubed minus a negative x becomes plus x. So if we simplify this, really all we can do, this becomes negative 9x, and then this negative x cubed, remember, will be a negative x cubed. So whenever it's an odd power, you will get that negative out in front. Whenever it's an even power, it will just become x to that even power. Now, this doesn't look like what we started with, but with fractions, we also have to make sure that by multiplying the top and the bottom by the same thing, that we can't get back to what we started with. And here, notice this is a negative 9x where we had a 9x here. So if we multiply the top and the bottom by negative 1, which is really just multiplying it by 1, we get 9x, and when we distribute this negative 1, we get 7x cubed minus x. So we didn't change anything there. We really just divided out a common factor of negative 1. We kind of reduced it. And that got us back to exactly what we were starting. So this one is even. Okay, we've got one more function here. So we've got f of x equals x over x squared minus 1. So I'm going to write that as y equals x over x squared minus 1. Let's first check if it's even. So we're going to plug in a negative x. So y equals negative x over negative x squared minus 1. Now the negative x squared, which would be negative x times negative x, the negative 1 times the negative 1 become 1. So this will be negative x over x squared minus 1. Now we do have to make sure that that kind of multiplying by a negative 1 and a negative 1 doesn't give us what we started with. And if we do that, we would get x over negative x squared plus 1. And that doesn't give us the same thing as what we started with. So this function is not even. Okay? Now, let's look at odd. So there we have to replace y with negative y. So we'd have negative y equals negative x over negative x squared minus 1. Now, if we just do the negative x squared, just becomes x squared. Now we want to get y by itself again, so we're going to multiply both sides by negative 1, which is like negative 1 over 1. So here we're just really multiplying the numerator by a negative 1. So this becomes y. Negative x times negative 1 is x. Over the bottom will still be x squared minus 1. And that is what we started with. So this one is an odd function.